So welcome back. This is part 2 in our series on debunking some of the many myths surrounding solar energy. And as I mentioned in the first part, the purpose of this is not to tell you whether solar energy is good or bad, or to proclaim that it's not good. It's to provide you with some ideas and concepts and data that hopefully you will know enough about energy and electricity that you will be able to make your own decisions based on some of the questions I raise and some of the data, and you'll be able to research it yourself to come up with your own conclusions, rather than what a lot of people do in complex subjects like this, which is kind of rely on, they heard it on the internet and therefore it sounds good, so they believe it. So the goal here is to give you some data and some ideas to allow you to further your education and to make up your own mind based on fact, not just on emotion or what you hear. So in the first video, we talked about some of the common myths and hopefully provided some data to help you decide about what you think is the truth. The things we talked about in the first video are whether solar is really free energy. And that seems to be a very common myth that people like to believe, that it's free energy. And we talked about how, no, it can actually be one of the most expensive forms of energy to the average user. And we explained some detail and some of the numbers surrounding that. The next one we talked about is the strange, I consider a very strange belief that people seem to think that this solar technology is somehow awesome new technology, when in fact we showed in the first video how it's been around for 40, 50, 60 years. So, and it really hasn't changed in all those decades. I mean, the efficiencies and everything else really haven't changed very much. So you might want to check out that video to see what some of the history is. And we also talked about the apparent belief that people have in order to support their beliefs about how wonderful solar is, that it's perfect and it's everywhere and you don't have to worry about it being unreliable. We started talking about how, in fact, it's very unreliable and it's not ideal in any way and can be very expensive. And we're going to pick up on that in this video and talk more about what I consider to be kind of the elephant in the room that people never discuss. And that is, what do you do if you're using solar power, but the sun sets or the clouds come over and you ultimately have no electricity coming into your house or to power your appliances because there's no sun? What do you do? And that is a huge issue, and it can be very challenging and expensive to try and solve that. And the next thing we're going to talk about is batteries. People, when presented with the facts about the unreliability of solar, they kind of fall back and say, well, you can get batteries to store the energy. When you've got sunlight, you can charge the batteries, and when you don't have sunlight, you can just get the energy out of the batteries, kind of like charging your cell phone. You charge it up and unplug it, and then you can use the battery in the cell phone. That sounds like a nice idea, but we're going to look at some of the data behind that and show how it is really not a good solution for most users. And then the final issue is kind of a minor issue. People, when they have nothing else to say about solar, they just say, well, it's good for charging my cell phone and that kind of thing. And we're going to talk about how, there are much better options. So the big question we're going to talk about, and again, this is what I consider to be the elephant in the room, something that is a very big issue that nobody seems to want to discuss. They're too busy saying how wonderful solar is. And the ultimate question is, what do you do when the sun goes down or when the clouds come over? And we talked in the last video about what the ideal solar radiation is when the sun's out, how much solar radiation falls onto the earth, and compared that with the actual numbers. And this yellow graph is something we showed you how you can get copies of the solar radiation graphs for just about any day you can think of, last week or last year, at just about any location, at least in the United States and probably around the world. you can get these graphs for your location for any day, and you can find out what the actual solar radiation was at your location or any other location. And it gives you in watts per square meter. And here's the numbers for this particular graph. And it goes through the 24 hours of the day. And start out, at nighttime, there's no solar radiation. And in the morning, it starts to pick up as the sun comes up. And you can see in this graph, a lot of clouds coming over to block the sun. Normally, ideally, you would have, up towards 1,000 watts per square meter if perfect sunlight, which you never get. In this case, you're only up around 400, 450 watts per square meter, which implies it's a more normal cloudy day, and the clouds come over and you're up to 200 watts, and then suddenly you get a dark cloud and the solar drops down to maybe 50 watts per square meter and then builds back up. And with just a moment's notice, suddenly the cloud comes over and suddenly your solar radiation drops substantially. And you can see here, you get up to 450, it drops down to 100. So that means the output of your solar panels is also going to drop as this sunlight drops. So the question becomes, if I'm running my appliances and I've got 450 watts per square meter onto my solar panels and suddenly it drops, all my appliances are going to shut off. What am I going to do? All right. So let's answer that with a scenario that will hopefully drive home some of the things you need to consider. All right. So let's say here's my house, and I have spent, as we showed in the last video, maybe $5,000 or $10,000 or $15,000 or $20,000 to put a whole bunch of solar panels and all the associated equipment on my house, so I can gather the free energy, right? And again, we said it was going to be not free. It's going to cost you, upwards of $10,000 or $15,000 or $20,000. So let's say I've got a beautiful sunny day, no clouds in the sky, and let's say I'm drawing out of these solar panels 2,000 watts or 2 kilowatts, and that is providing power to my electric water heater, my electric stove, my refrigerator, my lights, my electric chargers, my TV, my microwave, my air conditioner, whatever I'm running at the time. I'm getting a lot of electricity from my many, many solar panels, and I'm doing fine. Now, let's also say that the power company decided to be environmentally friendly and green, and they had previously a bunch of carbon-emitting power plants that burn coal and gas and oil and were very environmentally unfriendly, and they decided to get rid of all those and replace them with solar panels. And they had power plants that were just solar power plants. And let's say this power company has 100,000 kilowatts worth of solar panels and solar power plants. We're using 2 kilowatts, and let's say they've got 100,000 kilowatts, which means, maybe they've got 50,000 customers in this utopia of solar energy where they're taking, whatever they need from the sun directly, and you've got 100,000 kilowatts of energy going to these 50,000 customers, and life is grand, okay? So let's now assume that, a cloud is going to come over. And as we showed in this graph here, if the cloud goes over and blocks out the sun, and maybe it could be a statewide storm that suddenly comes through, and for the entire state, it becomes black clouds, and the sun energy drops. So, for example, it could be up at 450 and drops down to 50 or 100. So what's going to happen? Well, you're in your house, you notice it gets really dark outside. Well, you might start to notice that, the lights are dimming and the refrigerator is making these grinding noises because it doesn't have enough power, and maybe the TV shuts off and the microwave doesn't work. And, if it gets really bad, you're going to go down to zero energy, right? Because there's no sunlight. And it's like nighttime where you have no power coming out of your solar panels. So what are you going to do? You got no power, it's 1 p.m. and suddenly you've got no power and nothing runs. And if you've ever, been in your house and suddenly the power shuts off because there was a storm or there was a problem with the power company and the power shut off, you know exactly what it's like when, you got nothing. So what are you going to do? Well, the power company also has, 100,000 kilowatts of solar panels, but, the clouds came over and they also went to zero. So what, you've got nothing. You have your solar panels are dead. The power company provides nothing. So you got to step back and think, what am I going to do? I've got no energy. And this is really no different from nighttime where, if everybody's got solar panels but there's no energy, there's no sunlight, the sun is set and it's dark out, you got nothing coming out, so it's all, you're going to have no electricity in your house. The lights will be off, it'll be black, and, you'll have nothing. So what are you going to do, right? You're sitting at home, you have no solar energy. The only option is hope that the power company has some electricity. And again, if all they have is solar panels, they got nothing, all right? So what you would like is if the power company still had their carbon emitting gas or oil or coal-fired power plants like you see here, that otherwise, without all this solar, would provide you with electricity 24 hours a day, 7 days a week. It's extremely reliable. As you know, you can always plug into your outlet and get power from the power company. And that's why, because they've got these very reliable power plants that don't rely on solar. You just, pour in gas or oil or coal and it burns it and produces steam that runs generators, and it's always available. And that's a really nice thing to have. And it turns out, as we showed in the first video, it's very cheap, right? 13 cents for 1,000 watts for an hour. That's really cheap and it's always available. So it's really nice. But the downside is, you got these carbon emissions into the atmosphere and it's not environmentally friendly. So it's got good points and it's got bad points. So what you want is for them to have both, right? I mean, most people would say, well, I like the solar, so they should have solar, and they should have as much as they can of the solar, which means you keep the 100,000 kilowatts of solar, but also because they need power when the sun goes down, they also need to have 100,000 kilowatts to serve all their customers, their 50,000 customers, of gas and oil or coal, right? So now you're talking about, if you think about it, you're saying, well, I want them to have both. Well, where are they going to get the money to build, 200,000 kilowatts of solar, gas, and oil plants, where before they only needed half of that? Well, it's going to cost a ton of money to do that, to have both. Where are they going to get the money? They're going to get it from you. They're going to charge you in the bills, and they'll get it from the government as subsidies, and that will come from your taxes. So it's going to be a very, 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 very expensive proposition to get the benefits of reliable electricity and also get your solar power environmentally friendly. So again, this isn't saying that solar is bad. This is just saying, you need to think a little bit deeper about what the implications are of saying, we want everything to be environmentally friendly solar, when in fact, maybe at the end of the day, you don't really want that. Maybe you need to think a little bit deeper about how to solve the problem. So, the next thing that people like to jump to when they are confronted with the unreliability is, well, we'll just install batteries, and the batteries will, when the sun's out, you'll charge the batteries, just like I'm charging my cell phone. You'll charge the batteries, and when the sun goes down, it's nighttime, I just take the energy out of the batteries to power my equipment, all my appliances and stuff. Well, that sounds like a nice idea. And it's, technically it's a solution that you can use. However, let's look at the actual numbers. I'm recording this the first part of 2020. And at this point, the largest utility battery installation can provide around 100 megawatts for an hour. And I believe that's installed in Australia. And here's a photo of it. And again, 100 megawatts or 100,000 kilowatts for 1 hour. It stores that much energy. Now, let's take a look. Let's put that in perspective. The state of California, the peak demand, it's called the demand, the peak requirement for electricity in the entire state of California is around 50,000 megawatts, okay? So at the most, the highest demand day, which in California is generally in the middle of the summer when everybody's got their air conditioners on, they require 50,000 megawatts of energy at the peak time, okay? If the largest battery is 100 megawatts, this is 500 times, the state of California requirement is 500 times this largest battery installation. Now the state of New York is kind of similar, 20,000 megawatts. So it's 200 times the size of this largest present day battery installation. So if you think about, you can say you need batteries, but, imagine trying to store energy. This is only a 1 hour storage. Try to store energy to supply this state of California or the state of New York or any other state for just an hour. You would need thousands or millions of these batteries to supply the needs of the entire US for only an hour. So think of the many hundreds you'd need and how much that would cost and how much land you would need. And now you've got these batteries and you have to question how environmentally friendly are the batteries and all of the costs associated with that. This is a nice idea, but when you look at the numbers, you have to think, is this really a good option, or is this something that may happen in 20 or 30 or 50 or 100 years? But right now, it's really not an option. So again, this is not saying that batteries are not good. It's just, there's a lot more to it, and you have to decide, are we willing to spend all this kind of money to get this solution, which really has a lot of negatives? Now, on a more personal level, let's look, when talking about batteries, let's look at a typical residential installation where we've got a bunch of solar panels and we spent money to put solar panels on our roof. Your typical residential daily power usage is around 10 kilowatt hours. Now, you can go on your utilities website probably into your account, and they probably have data showing when they read your meter how many kilowatt hours you've used that month. So what I did is I looked at my last 2 years worth of usage and averaged it out. It goes all over the place, but the average is around 10 kilowatt hours per day, all right? So if I had solar panels and I wanted to store 1 day's worth of power usage in case the next day there was no sun, I could get, for example, a Tesla Powerwall battery that can provide a little bit more than that, 13.5 kilowatt hours. The cost is around $6,000, okay? And that doesn't include installation. Now, you can check and see what numbers you come up with when you watch this. Again, this is just to give you some ideas about doing your own research, and maybe you can find a better battery or whatever. But we're talking about a lot of money in order to fix the problems and the challenges with solar power. It's very, very expensive, and it's really, this is only to help you if you can charge your battery all day. So for example, you have to not use your battery an entire day and just charge it with the sun so that it will be available all the next day if, we get a storm coming over or something. So again, these are the things you need to consider. Now, the last issue I'm going to talk about is kind of a minor issue, just to show there are other options. People think, well, I can use solar power to charge my cell phone. Well, yeah, you can, but, you can buy a battery that is designed to provide a backup for your cell phone, and it costs about $20. And down here is an image of the one I have. and it provides 10 amp hours of current at 5 volts, which means it gives you 50 watt hours of energy if you charge it up completely. And it will take 4, 5, or 6 hours to charge this thing completely if you plug it into the wall, but it will give you 50 watt hours. Now your cell phone, at least my cell phone, uses about 5 watts typically as I'm using it. So if I have 50 watt hours, I can typically operate my cell phone continuously using this battery for 10 hours. So if you add that to what your cell phone battery has internally, you can get a good day's worth of use of your cell phone just using this as a backup. And it's only $20. And the cost to charge this battery from your utility when you plug it into the wall is like half a cent. It's less than 1 cent. 50 watt hours and 13 cents a kilowatt hour if you do the math. It costs you virtually nothing to charge this battery. So it's a really good option as a backup. Now, if you want to use a solar panel, it's going to be a challenge because you can get a 25 watt maximum solar panel for about $60, and that's a max. And again, we said max is assuming you've got 1,000 watts per square meter of solar energy, when in fact it might be only a tenth of that. So you might be only getting 2 to 5 watts coming out of your solar panel, depending on the sunlight, and that's at 12 volts. So you would have to have a converter to put it 5 volts to charge your cell phone. And it's 18 inches by 14 inches, so it's a fairly big solar panel. And it costs, it weighs a few pounds. So again, it's kind of awkward to, you can get a solar panel and do it, but it's going to cost you $60. And the payback, 1 cent every time you charge this battery, the payback is going to be many, many, many years to pay off the $60. So again, you can do it, but the real benefit is very questionable. So that's about it with this video on the myths surrounding solar power. Again, this is not to say solar power is bad. It's just to give you some things to think about and do your own research for your own situation and determine, what's really a good idea for you to do. And, also keep in mind, like we said in the first video, this technology is not new. This has been around for 40 or 50 years at least. And really the efficiency hasn't changed in the solar panels. There's not a lot that's changed. People kind of act like, oh, this is, has changed so much. Really, it hasn't. And maybe that's why in the last 40 or 50 years, you haven't seen a lot of people put solar panels on their roofs because it's really not that much of a benefit. It's very expensive, very unreliable. And, is it really worth it? If it was really worth it, people would have started it 20, 30, 40 years ago. So again, keep that in mind. Maybe there's a reason. So solar is extremely unreliable and unpredictable. Clearly, that's the case. You can do your own research. You can look at your own, as we suggested, you can find this solar energy hitting the earth. You can find graphs of that. It's good, but very expensive for remote locations where you have no other option. And of course, it's very popular with folks with RVs because they have no way to plug into the utility in most cases, so it's all they've got. But again, very expensive. So therefore, if you want 24/7 reliable electricity, you need reliable power sources to back up the solar. You might need a emergency generator, or you might need to have the utility have a lot of reliable backup, non-environmentally friendly power sources. And that will cost big dollars for duplicate power plants, okay? And presumably those will probably not be environmentally friendly. So again, things to consider. So hope this has been helpful. Again, it's not to say anything is right or wrong. It's to give you some information and to encourage you to do your own research and come up with what you think is right or wrong and what you should be doing. So hope this helps. Take care and have a really good day. Thanks.